Welcome to the Expert Sage. This is the third lesson on the number shortcuts. Primarily, we will be doing with the topic prime numbers. Please watch this lecture in one sitting only. Try to make notes as far as possible. We give lots of funders. Also, if possible, try to give the concept test after the lesson, which is available on our app. So, there's a very basic concept you must be knowing that what are the prime numbers? Prime numbers are the numbers which has exactly two factors, and which are those two factors? One and itself. Example 2 and 3. And the numbers which have more than two factors are known as composite. Example 4, 8, and 12. Right? Example 4 has three factors, 1, 2, and 4. So this is a very basic, everyone must be knowing. Now, how to check whether a number is a prime or not? Let's see if I take 119. What I'll do, I'll start dividing it with the prime number. The smallest is, let's say, 2. It is not divisible by 2, right? It is not divisible by 3 as well. Till where will I go? I need to go till find the nearest square of this 119. The nearest square is 121. Whose square it is? It's square of 11 square. So max to max, I need to go till 11. So after 3 with 5, this is not dividing. With 7, if you check with 7, it gets divided. That means 7 is one of the factor of this number. So this number cannot be a prime number. On other hand, let's say if I look at this 173, nearest square of 173 is 169. So 13 square, I need to check till 13. So with 2 it is not dividing, with 3 it is not dividing, with 5 also not dividing, with 7. You only need to check the prime numbers, huh? Not all other numbers. So 7 to the 14 also not 7. With 11 also 11, no. With 13 also no. So this number is a perfectly prime number. 173 is a perfectly prime number. So I hope you got this one. Now remember 2-3 things, that one is neither prime nor composite. Why? Because one has only one factor, one and itself. One is the same number, right? So it doesn't fit in the category of exactly two factors and also more than two factors. So it is neither prime nor composite. Now regarding 2, 2 is the only even prime number we have, and it is also the least prime numbers. All other prime number except 2 are odd. Right? So please keep this in mind that about 2. The next thing you should remember is many times you need to calculate the prime numbers, right? So keep this thing in mind, it will be handy. That from 1 to 100, there are total 25 prime numbers, right? If a situation comes where you need to count a prime number, it may happen in a pressure situation that you take 39 as a prime number, whereas it is not a prime number, right? So breakup of this is out of 1 to 100, the from first 1 to 50, we have 15 prime numbers, and next 10 are from 51 to 100. So please keep this in mind. Also remember, there is only one set of consecutive numbers which are prime, and that is 2 and 3. As we just saw, apart from 2, all the prime numbers are odd. So I know the two consecutive odd numbers, the difference will be at least 2. Right? So there is one set of numbers which has a difference of only 1, that is 2 and 3. Also, there is one pair of one triplet, in fact, which has a consecutive difference of 2. That is 3, 5, and 7. The next thing you should keep in mind is this is very important, that all the prime numbers are of the form either 6k plus 1 or 6k minus 1, exception 2 and 3. You must have seen here in many books, but what is the logic behind this? We'll see the logic as well. Okay. Before that, just remember, any prime number or any number, if it is broken into some parts, a into b, some product of two numbers, it can never be a prime number. It can never be a prime number. Why? Because if I say one number is 2 and another number is 3, it will be what? 6. So it can never be a 6 is not a prime number. 2 and 3 will be the factor. The only case the possible is the one number is 1 and another is prime, that is p. But this will not be something 1 into p because it is nothing but p into p only. So remember, any number can, if it is broken into two parts, it can never be a prime number. So if I see, whenever I divide anything with 6, there are 6 types of remainder possible. Either I'll get 1 as a remainder, so that number will be 6k plus 1, or I'll get 2 as a remainder, so that number will be of 6k plus 2 form, or 6k plus 3, or 6k plus 4, 6k plus 5, or it can be a multiple of 6, leaving remainder 0. So leave the first one. Now second, I can take 2 common out of 6k plus 2, right? So this can be written as 2 into 3k plus 1. Now I've broken down into two parts, multiplication of 2. It can never be a prime number, right? Whatever may be the value of k, it is will be a multiple of 2, so sure it will not be a prime number. Similarly, out of 6k plus 3, I can take 3 common, and this number will be what, 2k plus 1. So this can never also be a prime number. From here also I can take out of 6 and 4, I can take 2 common. So surely this will not be a prime number. 6k plus 5, I can't say anything. And 6k, obviously it is not a prime number, as it can be written as 6 into k. So I'm only left with 6k plus 1 and 6k minus 6k plus 1 and 6k plus 5. 6k plus 5, with a 6, it gives a remainder of 5. I can also say that if a positive remainder is 5, my negative remainder will be minus 1, right? So these are the only two forms which remains after dividing with 6. So that is the logic of this, that any prime number will be of the form 6k plus 1 or 6k minus 1. Reverse is not true. Like, let's say if I say 49, 49 is a multiple of 6 plus 1, that is 48 plus 1, but it is not a prime number. But any prime number will be surely of the form 6k plus 1 or 6k minus 1, exception being 2 and 3. Now, another thing you should remember is that all the prime numbers are of the form 2 to the power 2 to the power n. Right? The logic of this is, there's a one property in maths that a to the power n plus b to the power n upon a plus b, it will always be divisible by a plus b, provided n is an odd number. If I check, let's say simple funda, if I check keep one n as 1, so what will happen? A to the power 1, b to the power 1, it is divisible by a plus b. That means a plus b is one of the factor of it, so it can never be. So if I say out of 2 to the power 4 plus 1 or 2 to the power 6 plus 1, which will be a prime number, obviously, if you must be knowing the value, the 2 to the power 4 is 16 plus 1 17, 2 to the power 4 is 6 is 64 plus 1 65. This is not a prime number. Why? Because 6 is not a 2 ka power. It's a 2 ka multiple. I need a 2 ka power. Whereas 4 is a 2 ka power, right? 4 can be written as 2 square. So this is a perfectly prime number. This is an important point you should keep in mind. Now let's see the application of all these fundas. So question number 1, CAT 2006 one. The number of employees in a company is a prime number and less than 300. The ratio of number of employees who are graduate and to that who are not graduate can possibly be, he's asking possible value, not the exact value. Now the employees can be of two categories, as he's saying, the one part of the employees are graduate, another part of the employees are not graduate. So the total employees will be nothing but G plus NG, that is graduate and not graduate, they are the employees, and I know this has to be prime number, right? Employees total has to be a prime number. So you just need to do the total and need to check whether they are prime or not. So if I say that this comes out to be 181, this comes out to be 187, this will be 186, and this will be 189. So you know the how to check the process of prime number, right? 186 can never be a prime number as it is a multiple of 2. Even 189, it is getting divided by 3, right? So it is also not a prime number. 187, what are the closest square? So 187, the closest square, you can say it is divisible by 11, right? 11 ones are 11 sevens. So also this cannot be a prime number. So obviously my answer has to be 181. Let's check whether it is a prime number or not. Till where I need to go? It's the closest square is 196. So I need to go till 14, right? 14 se niche. So with 2 is not divisible, with 3 is not divisible, with 5 is not divisible, with 7 also not divisible, 11 also not, and 13 also not. After 13 there is no prime number. So the answer of this question is A. Now this is the second question. If P is a prime number such that in this range, how many values we can take. So the same logic which we have used for the derivation of 6k plus minus 1, right? That any prime number cannot be written as a product of two numbers. So what is the lowest number you can see here? It has to be greater than this number. The lowest number will be 2020 factorial plus 2. Then next number will be 2020 factorial plus 3. Next number will be 2020 factorial plus 4. And last number will be 2020 factorial plus 2020. Right? I hope everyone knows the meaning of factorial. That means 202 factorial will be have nothing but one product of till 2020. So can first be my prime number? No, because in 2020 factorial I have 2, so I can take 2 common out, right? So this will be 2 into some number, whatever might be that number, but I've broken into 2 parts. So for sure I know this cannot be a prime number. Similarly, I can take 3 out of here. So again, this cannot be a prime number. I can take 4 out of here common, right? Because 20 factorial has every number among them. Even the last one, 2020 factorial has 2020, so I can take 2020 as common. So the answer of this question is perfect 0. You don't have any prime number lying in this range. Okay? Third question. It's similar to that only. That Z is a CAT 2017 question. Product of first 31 natural numbers. If X is what? Z plus 1. So I need to find. So what is Z? Technically Z is nothing but 1 into 2 into 3 till 31. So basically Z is nothing but the 31 factorial. And I know X is what? Z plus 1. And he's asking us X plus 1, X plus 2. So if I convert it into Z, X is Z plus 1. So I know this can be written as Z plus 2. This can be written as Z plus 3. This can be written as Z plus 4. Dot dot dot. This can be written as Z plus 30. And last can be written as Z plus 31. So now the same funda, I know Z is what? 1 into 2 into 3 into 31. So it has 2 in it. So I can take from this 2 common into something. So again, this cannot be a prime number. Similarly, I can take 3 common out of here. Similarly, I can take 4 common out of here. And from last as well, as we have the limit of Z till 31. So last one also 31 can be the common out. So again, answer of this question is 0. So then the number of prime numbers among this value, the answer is none of the above 0. Okay? You will never get any prime number out of this range. Coming to question number 4, we just saw that any prime number has to be of the form 2 to the power, 2 to the power n plus 1. So it's hardly a matter of 5 seconds. So what is the answer? At 70 is not a 2 ka power. 96 is also not a 2 ka power. 245 is also not a 2 ka power. The answer of this question is 2 to the power 64 plus 1. Question number 5. It's again a CAT question and a good question. That the box contains 60 tickets and these tickets are numbered ABC, let's say. Such that we want A into B should be equal to C. So question is how many tickets can never be picked up? Okay. So we need to concentrate which can never be the values of A, B or C. So I know if I see on the logic of prime numbers, is prime number possible? Let's say if I pick 11. Obviously 11 can never be a value of C because 11 cannot be written as product of two numbers. Only way is to write is 1 into 11, but 11 cannot be picked up twice as B and C are the different numbers, right? So prime number obviously can never come at the place of C. Also remember, one can never be picked up because one के साथ आप कुछ भी ले लो, that number will repeat. Right? So one part I got that one can never be picked up. So one तो पक्का नहीं हो पाएगा. Ticket number one can never be picked up. Now, but can 11 is never possible? No, 11 is possible. How? If I try to pick up 11 among A and B. So if this is 11, and what is the lowest another ticket I can pick up? I know I cannot pick up one. The lowest ticket which I can pick along with 11 is 2. So that is 22. So this can be possible, right? But he's asking which is never possible, which can never be picked up. So the logic is in this question is the prime number in the second half. Prime number in the second half you can never pick up. Right? Try to think. Let's say second half means it's 100. Okay, this is actually 100, not 60. So what is the second half? This is 51 to 100. Take any prime number from 51 to 100, let's say 53. So if obviously 53 cannot take a place of C, but if I try to pick up with 53, the least number that is 2 also, the product will be 106. And I don't have ticket number 106 as my limit is to the 100. So any value after the second half can never be picked up like 97. So we know that 51 to 100, how many prime numbers are there? 10. So in total, this 10 prime numbers plus ticket number 1, because 1 is neither prime nor composite, that means total 11. 11 numbers can never be picked up. So this is the answer of this question. Okay, now question number 6. If A, B, C, D are the prime numbers, okay, not necessarily consecutive, and A plus B plus C plus D plus A is 482. Then how many values of A to the power 5 is or are possible? Let's say if I take let's say if I take the case where A is not equal to 2. Okay? I know the only one prime number is 2. Apart from 2, the all prime numbers are odd. So basically A will be odd, this B will be odd, this C will be odd, this D will be odd, and E will also be odd. And I know what is odd plus odd. Odd plus odd is always even. So this will result in even, this will result in even, and this will be odd. And also I know what is even plus even is even, and even plus odd. The net result of this will come out to be odd. But I know the resultant what I want 482 is even. So this is not at all possible by taking all the numbers of A, B, C, D as the ortho. You need to make sure that you need to take at least one even number. And I have only one even prime number, that is 2. Right? So you need to take 2, and 2 is nothing but the lowest value. So it has to take the value of 2 because it will be even and rest 4 will be odd. So the entire result will be even. So the only possible value A can take is 2. So the answer will be 2 to the power 5. But he's not asking what is the value of A to the power 5. He's asking how many values he's asking, right? So it has only one value possible, that is 32. Please don't mark answer as 32. So answer of this question will be 1. Question number 7. Now, again a good question. What is saying there are two prime numbers P and Q. Both P and Q are less than 30, where P is less than Q as well. So how many cases would P, Q is also prime? So what he wants, P plus Q should be prime. Is it possible if if I don't take 2, if I don't take 2, like let's say P is not equal to 2, what will happen then? Both this will be odd and this odd plus odd, I know it will be even, and any even number can never be a prime number except 2. So for sure, I know that P has to be 2. There is no option. Okay, so the value of P has to be 2. So what remains is Q. So I just need to check whether the resultant is prime or not. So it's a proper hit and trial question now. P and Q are both prime numbers. You need to go till 30. So after 2, what do we have is 3. What is 2 plus 3? 2 plus 3 is 5. It's a perfectly prime number, so it will go. After 3, it is 5. 2 plus 5 is what? 7. This will also go. 2 plus, after 5, the next prime number is 7. Let me write the prime numbers first. After 7, we have 11. We have 13. We have 17. We have 19. We have 23 and 29, right? This till this I need to go. So what is 2 plus 11 is 30. 2 plus 7 is 9. This will not a prime number. 2 plus 11 is 13. This is a prime number. 2 plus 13 is a 15, not a prime number. 2 plus 17 is 19. It's a prime number. 2 plus 19 is 21, not a prime number. 2 plus 23 is 25, not a prime number. 2 and 29 is 31. This is a prime number. So how many tick we got is 1, 2, 3, 4, and 5. So 5 has to be the answer of this question. So question number 8 now. If a plus 1, a plus 3 are the prime numbers, then the possible number of solution. We know the property that there is only one pair which has a difference of 1, that is the two consecutive numbers. And what are those two consecutive numbers? Nothing but 2 and 3. So this will have only one possibility, that a has to be 2, then second number will be 3, and third number will be 2 plus 3, 5. So this is only one pair, one way possible where we will have this condition satisfied. Now question number 9. Again a good question. N square minus 33, n square minus 31 square minus 29. Now look at the difference between them. What is the difference of the first two numbers is 2. This numbers is also 2, and we know that there is only one set of 3 numbers which have a difference of 2, and what is that number? 3, 5, 7. So this is only possible when this thing is equal to 3, and this thing is equal to 5, and this thing is equal to 7. So you can just check the value. N square minus 33 has to be equal to 3. That means n square should be equal to 36. So that means n will be equal to 6. So, and for the value of n, it will be 6. So there is only one way out. So how many values n can take? It can take only one value, that is 6. Answer is 1. Now again a good question. Question number 10. There are 4 numbers, x, y, x plus y, and x minus y. If all these are prime numbers, also I know that I need to find the sum of these prime numbers. So again, can I did not take 2 is one case. If I don't take 2, okay, so let's concentrate on x plus y. As both the numbers are prime, so this will be odd because I'm not taking 2. This will also be odd. And what is odd plus odd? Odd plus odd will be even. So this is for sure one of the number has to be 2. I can't take a case where 2 is not included. So I need to include 2. So now the question remains, with whose value I can take 2. If I take x equal to 2, let's say, so x plus y will be what? X plus y, this 2, and y is 3. So this is 5, this is a prime number, no issues. But x minus y, there will be issue. 2 minus 3 is minus 1, and minus 1 is not a prime number. So x equal to 2 I can't take. Only remains the possibility is I need to take y equal to 2. If I take y equal to 2, so this will become x plus 2. This will become x minus 2, right? And let's say there's another number, right? This is x. So what is the difference between the consecutive terms? If you can see, this is 2, this is also 2, and we know there is only one set of 3 numbers which has a difference. So this has to be, the highest number will be 7, right? This will be 5, and this will be 3. So if you can see, this is a consecutive difference of 2. So this what is the one number remaining? That is nothing but y. That y is we have taken as 2. So these are the four values we have got. Now what is he asking? This question is sum of these prime numbers. So what will be the sum? That is nothing but sum 7 plus 5 plus 3 plus 2. That comes out to be how much? 17. So is 17 is a prime number. So answer of this question is D. Okay. I hope you got the logic of this. Moving on to the next question. Question number 11. It's a CAT question, CAT 2003, that a and a plus 2 and a plus 4, and then possible solution for that. So another same thing again, right? The difference is 2. Difference is 2. The only way out possible is that it has to be 3, 5, and 7. So the answer of this question is 1 only. Let's look at the general way of doing this question, right? If I twist this question around, then how shall I deal with this question? Obviously, I'll start with 2. If I start with 2, this number will be 2 and this will be 4. 4 is not a prime number, so I should stop here. If I take a as 3, 3 is possible, 5 is possible, and 7 is also possible. Now, till when I can go for a hit and trial? Obviously, you should not go for a hit and trial. We know the prime numbers are of the form 6k plus 1 or 6k minus 1, except 2 and 3. We have checked 2 and 3. So if I take this number as a as 6k, right? So this will be 6k plus 1. If I take a equal to 6k plus 1, a plus 2 will be what? 6k plus 1 plus 2. That is nothing but 6k plus 3. And I can take 3 common out here, and this number is broken into 2 parts, so this cannot be a prime number. So I'll not get a single prime number out of 6k plus 1. Another thing, if I take 6k minus 1, what will happen? In this case, this will be 6k plus 1, pretty much possible. And this will be 6k minus 1 plus 4. This will be 6k plus 3. Again, 3 can be taken common out, so this is not a prime number. For sure, only one case I'll get for a prime number is 3, 5, and 7. Okay. Let's see the another variation to this. If I take question number 12, here it is a plus 2 and a plus 14. So again, I'll start with 2. So this is 2, this is 4, this is not a prime number. I'll stop here. A as 3, this is 5, and 3 plus 14 is 17. I got another set of prime numbers, that is okay. Next step will be 6k plus 1 and 6k minus 1. If I keep 6k plus 1, this will be rejected, and this will be 6k plus 3 is not a prime number. Now checking at this step, 6k minus 1, and this will be what? 6k plus 1, pretty much possible. This can be a prime number. And last will be 6k plus 13. Now can you see? Don't mark this answer as 1. Many students will tend to make a mistake of marking this answer as 1. You can't say anything about this. This can be a prime number, this can be a prime number, this can be a prime number. You don't know the limit, right? There might be a value of k where this three things will be all these three things are prime number. Okay, you know the lowest prime number is 2, but to get the highest prime number, it's practically impossible without programming, and you can't find whether at any point you'll get at a very high number, whether this numbers will be 3 numbers will be prime. So the answer is cannot be uniquely determined, right? At least manually it is cannot be determined. Okay. So please remember this method, or else if you go for hit and trial, you will surely tend to mark this question as answer for this question as well. So moving on to the next question. For how many prime numbers this p square plus 3p minus 1 is also a prime number? So again, I'll start by putting values of p. The lowest value is 2. What will be in that case? There is nothing but 2 square plus 3 into 2 minus 1. That is 4 plus 6, 10 minus 1, 9. 9 is not a prime number, so this resultant is not a prime number. Now I can take next is p is 3. So it will be 3 square plus 3 into 3 minus 1. So p square is 3 square is 9. Okay. This value comes out to be 9 plus 9 minus 1, that is 17. 17 is a prime number. So at least we got the one number, right? Now 1 though is there for sure. So will my answer be 1 or cannot be determined? I need to check. And how will I check? The next prime number I should pick up is 6k plus 1, right? So everyone must be knowing what is a plus b whole square. A square plus 2ab plus b square. So if I keep 6k plus 1 here, so the value expression which I'll get is 6k plus 1 whole square plus 3 into 6k plus 1 minus 1. This comes out to be 36k square plus 12k plus 1 plus 18k plus 3 minus 1. So this can be written as 36k square. 12k plus 18k is 30k. This plus 1 minus 1 get cancelled out and this remains is plus 3. So I can take 3 common out of this expression, right? So 3 taken common out. So for sure this number will not be a prime number. So I got a surety that's any value of the form 6k plus 1 for the p will not yield me a prime number. If I take a case of 6k minus 1, what will happen in that case? It will be 6k minus 1 whole square plus 3 into 6k minus 1 minus 1. So basically 36k square minus 12k plus 1 plus 18k minus 3 plus 1. So the final expression is 36k square plus 6k. This is minus 1, right? 1 will get cancelled out, minus 3. So again you can take 3 common out. So again from this case also will not get any prime number. So for sure my answer is 1. So though it's a tedious way, but guys, you need to be sure for your answer, so you need to go through with the process. So moving on to the next question, question number 14. For how many integers then? Remember here is n is not a prime number, n is a positive integer. Right? So if I try to this, there's a simple quadratic equation. Everyone must be knowing how to break this up. So I need to factorize this in 24 in such a two numbers that the addition or subtraction gives me 14. The two numbers has to be 12 and 2. So I can write this number as n square minus 12n minus 2n plus 24. Right? So this can, from this n can be taken out and from this minus 2 can be taken out. The final two numbers will be n minus 12 and minus 2. And I know this should be what? Prime number. We know the prime cannot be written as a product of two numbers. That is only possible when one of them is 1 and another is p, right? So I may have two cases, that this is 1 into p or p into 1. That is only two cases possible, right? So if I take this first case, so according to this first case, my n minus 12 has to be equal to 1. So what will happen? N minus 12 equal to 1. That means n is equal to 13. Putting this n as 13 here, this is 2, I'm sorry. Putting this n as 13 here, just check whether I'm getting this number as a prime number. So 13 minus 2, that is 11, and 11 is a perfectly prime number. So my n equal to 13 will satisfy. So I got one value. Now look at the second part. If I take this as prime number and this as 1, so I know n minus 2 is equal to 1. So n minus 2 is equal to 1. That means n is equal to 3. So if I keep n here, so 3 here, that 3, this will come out to be minus 9, and minus 9 is not a prime number, so n equal to 3 will not go. So again, answer of this question is there is only one integral values of n for which it will satisfy. What is that value? 30. So answer is 1. So going on to the last question, question number 14. Now note here n is the integral value. Nothing is said about n that n is positive. So n can take either positive as well as negative. So n square plus 4n minus 77. So the two factors will be what? 11 and 17. sorry, 11 and 7. I want positive, the bigger number has to be positive and this has to be negative. So the two factors in which I can break is n plus 11 and n minus 7. This has to be prime. Now again, the only two, in fact, it will have four cases because we have positive, negative both allowed. So it can take 1 into p or p into 1 or minus 1 into p or p into minus 1. You need to check all, right? So if I take the first case, that means first case I'm solving n plus 1, not 1, 11 should be equal to 1. So in this case, what my n will come out to be? N will be minus 10. So keeping minus 10 here, that this expression comes out to be prime number. Minus 10 minus 7, that is minus 17, right? Is not a prime number. Why? Because prime number is a property for the positive numbers only. Please remember this. Prime number is a property for positive. So first case is ruled out. Now look at the second case. Second case, n minus 7 has to be equal to 1. So second case, if n minus 7 is equal to 1, that means n is equal to 8. Keeping n here, I should get this expression as the prime number, that is p. So is that happening? 8 plus 11, it is 19. 19 is a perfectly prime number. So I got one value of n, that is n equal to 8. Don't stop here because n is not a positive integer. So I need to check out for minus as well. So this case, minus 1, that means n plus 11 equal to minus 1. That means n will be equal to minus 12. If I keep minus 12 here, what will happen? Then this part has to be equal to prime number, right? So minus 12 minus 7 minus 19 is not a prime number. So this is ruled out. Third case. Now the last fourth case. Here n minus 7 is equal to minus 1. So minus 7 equal to minus 1. My n comes out to be how much? 6, right? So keeping 6 here, does it give me prime number? So at n equal to 6, at n equal to 6, 6 plus 11 is 17, right? So I'm getting a prime number here. So there are two possibilities in this question where if I give value of n, and I will get this entire expression as a prime number. So the answer of this question is 2. So I hope you guys like the session. Okay? I just picked up a very important topic as far as CAT is concerned. You must be knowing prime numbers, but the only thing which I did is the exposure of the variety of the question. If you have liked, please like, share, and subscribe. Also, we have a program launch where you will get these things. Thank you all.